Hello friends, welcome to Learning with Edu4Sure. In this session of Advanced Python Programming, we are going to discuss the topic Decorators and Generators in Python. So let's get started. Let us see a brief overview of what we are going to cover in this session. We will talk about Introduction to Iterators in Python, some examples of iterators. Thereafter, we'll see some introduction to decorators in Python with examples of decorators. Furthermore, we'll discuss about introduction to generators in Python and see some examples of generators. Let us start with iterator objects. Iterator in Python is an object that is used to iterate over iterable objects like lists, tuples, dictionaries, and sets. The iterator object is initialized using the iter method. It uses the next method for iteration. The syntax includes iter, then within the brackets we have to pass some iterable, which can be some string, list, tuple, etc. This method is called for the initialization of an iterator, and it returns an iterator object. The next method returns the next value for the iterable. That is, when we are iterating through the iterable object, next method helps us to reach to the next value in the iterable. Then we use a for loop to traverse any iterable object. Internally, it uses the iter method to get an iterator object, which further uses next method to iterate over. This method raises a stop iteration exception to signal the end of the iteration. Let's now see how practically we can work with iterators. Now, here on your screens, you can see the Anaconda Navigator from where we can launch PyCharm IDE. Now here, PyCharm IDE is fully launched. Let us try and create a new project for working of iterators, decorators, and generators. Now here, let us name it as decorators and generators demo, and try to create this project. Now you can see this project decorators generators demo is fully launched up. Let us try and create a new Python file with the name demo1 in this particular project. So we try to create a new Python file with the name, say, demo1. Now you can see demo1.py fully in action. So let us enter the presentation mode to see how practically we can implement iterators. Now here you can see the presentation mode of PyCharm IDE demo1.py. So here we are going to see an example of a Python iterator where you can say the iterator is going to iterate over a value that can be anything such as a string, a list, a tuple, a dictionary, or a set. So let us try and create an example for iterators. So let me just put a comment for example of iterator using iter method. So let us create, first of all, an iterable value, say value 1, which can be some string. Suppose, say, I declare a string, hello users. So we have declared the string, hello users. Now we try to create an iterable object with the name iterable object 1. And this iterable object can be created using iter function. This iter method will be having, in the parameter, the actual iterating value. So that has to be the value. So we have designed this particular iterable object as the iterator for our value 1 string. Okay. Now we need to iterate over each and every value, each and every character present in the value 1 string. For that purpose only we have created the iterable object. For this we have to create and use the while loop. So we put a true condition in the while loop while true. This is going to work infinitely till we put some condition to break out. So in this, let us give a try-catch exception handling mechanism just in case to handle the stop iteration exception which may occur when the iteration is going to over, okay, through iterator. So nextly, we are going to use and retrieve one item value from the iterable object. So for that purpose, we need to use the next method. And in the next method, we are going to pass our iterable object. So iterable object 1 is going to be the parameter for the next method. Okay, so now the next thing that we are going to do is just we have retrieved the item, we have to print the item. So we are going to put the print statement, and in this we are going to pass the item that we have retrieved through the iterable object. So this is how you can print each and every value that you have retrieved using the iterator method. Now, once it is finished, once the entire for loop is finished and each and every value in the iterator has been iterated over and printed, it is going to throw and raise this exception known as stop iteration exception. You can see the IntelliSense is helping you to complete your code. So it is going to throw an exception known as stop iteration exception. This exception will be raised when the entire iteration is over, means no more value is left in the iterable object that we can iterate. So in case this exception is raising up, we need to call the break statement just to ensure that this is the breaking value. Whenever this iteration will start, we have to break out of the loop because our while loop is working infinitely. So this is how we can create and use iterator object, and we can iterate over each and every value using the next method. And we have to put a try-catch exception handling mechanism for the stop iteration exception. Let us quickly save it and run this code just to see what is happening. So we are going to run the code. Now, here we can see our entire string hello users. Each and every character is being printed in each and every iteration. So it is going to use each iteration to print a single character. So you can see the entire string is split into characters and each and every character is printed in each and every iteration. And when the entire string has finished printing, all the characters are finished up, at that point of time, this exception will occur, that is stop iteration will be raised up, and at that time the loop will break out and the printing will stop. So this is how you can use the iter method to create an iterable object for some particular values. This value can be a string as we have seen. Furthermore, you can use some list, tuple, or dictionary also in case you want to iterate over through those data structures. Let's go ahead and see what is a yield statement. Let us now talk about yield keyword or yield statement. The yield statement suspends a function's execution and sends a value back to the caller, but retains enough state to enable the function to resume from where it was left off. When resumed, the function continues execution immediately after the last yield is run. This allows its code to produce a series of values over the time rather than computing them at once and sending them back like a list. So we can save the state, we can resume our working from the last yield statement where it was actually stopped. So let us quickly see how we can work with the yield statement. Now, on your screens, you can see the code for using the yield statement with a for loop. Suppose we define a function, say func_odd, and in that we are defining a for loop, which is going to iterate over each and every value in the range from 0 to 10. That means from 0 to 9, each and every value will be iterated over. The 10th value, that is word 10, will be exempted. Because in Python, the last value is always exempted and you are going to iterate over one value less than what is the last limit. So next we are going to check for whether each and every value qualifies to become an odd number or not. So basically this function is going to calculate which of the value is an odd number. So for that, we are checking the condition if I mod 2 not equals to 0. So this value is going to check whether that value after division with 0 is giving the remainder as 0 or not. After division with 2, it is going to check whether the value is going to give a 0 or not. So if it's not giving a 0, that means it's an odd number, because an even number is completely divisible by 2 and will give for sure 0 remainder, but an odd number is going to give a non-zero remainder for sure. So if the number qualifies for becoming an odd number because the remainder is not equals to 0, then in that case, the yield statement is going to work and it is going to yield that value. Now what yield will do, it will just save the state for that particular number and will return the value wherever this function odd is being called. So let us see the next code. We have a print statement, the odd numbers are, and herein we have a for loop for j in func code. So you can see here this function odd is being called. This function odd is being iterated over. Each and every value which will be returned by this function will be iterated over by this iterator j. So for j in func odd, it is going to print the value of j. Now each time the function odd is being called, the value I is going to be returned by the yield statement. After returning that value, next time this loop in the function odd will start from the same point where it stopped previously for the previous yield statement. In the next iteration, the next value is going to be iterated by this for loop. So next time it is going to work with the same value from where yield statement stopped. So let us iterate it over. Suppose it is going to check for 0. Now 0 mod 2 is not equals to 0. This is false. So no yield statement will be executed. Now it is going to check for 1. 1 mod 2 is not equals to 0. It's true. So yield statement is going to work. Now function odd is being called in this for loop. So it is going to check for 1 and 1 is going to be returned here in j. Now in this loop, in the outer for loop, j value will be printed. That is 1 will be printed and the control will again go back to function odd. Now, the values in the function odd, the last value was 1 that was checked. So next value now going to be checked is 2. So it is going to check for 2. 2 mod 2 is equals to 0. So this is not qualifying for odd number. So next value it is going to check is 3. 3 mod 2 is not equals to 0. It's true. So it is going to yield again. So yield will return the value 3. Now 3 value will be returned here in j through function odd, and it is going to print the value 3. Now as soon as it prints the value 3, again the control passes through function odd and it is going to check for the next value 4. So in the same way you can see this function odd is halted for some seconds and then it resumes again when the next time this function odd is called, and it resumes from the same point where the last yield statement stopped. So this is how you can work with yield statement. Let us quickly run the code and see what output do we get. So let us run this code by clicking on run, and here we run this. So now you can see here we are getting a list of odd numbers. Now you can see we have a range of numbers from 0 to 9, out of which it is yielding only the odd numbers, that is 1, 3, 5, 7, 9. These are the same numbers which will be yielded through function odd and will be printed in the lower for loop. And after this, it is going to each time print it and resume from the very next number. So this is how yield statement is working with for loop. Let us now discuss about some advantages and disadvantages of using yield statement. Let us now discuss about some advantages and disadvantages of using yield statement. The yield statement stores the local variable states. Thus, the overhead of memory allocation is totally controlled. Furthermore, it retains the old state, so the flow doesn't start from the beginning every time, thereby saves our time during the iteration processes. There are also some disadvantages of yield, which are as follows. Firstly, yield may become erroneous in case the calling function is not handled or mishandled. Now, at times, it also may become hard to understand the logic behind using yield. Let us also discuss some of the applications where specifically yield statement can be used. You can see one major application of using the yield statement is a search application. It is one of the major applications. Why so? Because while handling large amount of data and searching particulars from it, yield can be used as we don't need to look up again from start, and hence it would save our time. Furthermore, there can be possibly many other applications of yield depending upon the use case or the application at hand. Let us now see some introduction to what are generators in Python. So a Python generator basically is a function that returns the traversal object and is used to create iterators. So a generator isn't just like a normal function which is defined by the def keyword, but uses a yield keyword instead of return statements. So you can say one of the identification of a generator function is that it is having no return statement. Rather, it is going to use the yield keyword in it for returning the control and value. So if the body of the function contains a yield statement, then it automatically upgrades to become a generator function. The yield statement is responsible for controlling the flow of the generator function. It pauses the function execution by saving all the states and is later yielded to the caller at successive function calls. So multiple yield statements can be used in the generator function, while return statement returns a single value only and just returns single statement can be used in the function. So as compared to the return statement, which can be used only single time, you can use multiple yield statements in order to yield multiple values altogether. So also by using the generator function, the local variables and the states are saved between the successive calls. This we have already seen in the previous examples. Furthermore, it traverses the entire items at once and no more value when found in iteration. It is automatically going to raise stop iteration exception. So we had also seen how it is raising this exception and we have to handle it manually in our code. So let us now talk about generator expressions. So what are expressions in a generator? So we can easily create a generator expression without using a user-defined function. It is similar to anonymous lambda function, because generator expressions, they are creating they create anonymous generator function. Anonymously, you can generate a complete list of values. You can calculate something and you can present it without any name, without specifying any name of the function. So generator expression is similar to Python list comprehension as well. The difference between the comprehension and generator expression is that the square brackets of list comprehension is replaced by round parentheses here. So in case of list comprehension, as in case of list, you can use square brackets, but in case of a generator expression, because it is similar to a function, so that's why we have to use parentheses or say round brackets here. Furthermore, list comprehension calculates the entire list in one go, while if you're using a generator expression, it is going to calculate only one item at a time. So let's get forward to the practical aspects of generator functions and generator expressions. So here on your screens, you can see in PyCharm we are trying to implement generator functions using yield statement and next function. So let's see, for iterating through the generator object, we are using here next method instead of the for in loop. So one of the a hint that you are using generator function is that for in loop is totally absent. You're not going to use for in loop, rather you are going to use the next method of the iterator. So for this purpose, you are using iterators also, yield statements also, and together they are creating a generator function. Let's see how. So here we have a definition of a function, say yield demo, and we are trying to here create some string objects. So string one is hello, this is string one, and at the same time we are trying to yield string one, that is, it is going to return the string one value and the control outside. Furthermore, after returning it, it will come back and start from string two. So yield resumes the call once the control flows back to yield demo. So string 2 is given as hello, this is string 2, and again we are trying to yield string 2, so it will be returned, and furthermore, once returned, the control will automatically come back and execute starting from string 3. So it will begin from the next statement just after the yield statement followed. Okay, so string 3 is equals to hello, this is string 3, so it is now going to yield string 3. So what we are trying to do, we have tried to create a generator function through yield demo. This function is a generator function. Why? Because it is automatically generating outputs, multiple outputs. It is generating one by one, and those outputs we can see and we can navigate using the next function. So you can see here we are creating an object. Okay, this is, although the name is object1, but this is not any class object, rather it's just a name to specify that we are going to get multiple string objects which will be returned through the function yield demo. So object1 equals to yield demo. So what it's going to do, it's this yield demo function is going to return or yield multiple strings which will be holded by object1. So when we implement the statement print next object1, so first next method will try to navigate to the first yielded output of yield demo. So first yielded output is the string 1 only. So it is going to eventually print the string 1. Hello, this is string 1. Similarly, when you use next time, next obj1, so it is going to access the next object returned by yield demo, which is going to be string 2. Furthermore, in the next statement, we have print next obj1 again. So in this case, again, it is going to print the string 3, which will be the object returned third time through yield statement in yield demo method. So this is how you can navigate through each and every object. You can iterate through objects using the next method. But you know, generator function is a logic. Don't think that generator function is some kind of a special function named generator that we can use. No. It is a logic, it is an implementation which is telling you to generate output through objects. So here we are generating output, you are yielding outputs, you are returning the values, you are resuming the calls each time the values returned. Okay, first of all, string 1 is returned, then again the call resumed for string 2. So you can see you are calling yield demo only once, but all three straight string objects are being yielded and they are accessed through next method, and you are able to access it through next method and able to print it through print method. But yes, one thing in line number 162, if you see, we are trying to print next object1 once more, that is fourth time. Now at this point it is going to throw an error if you try to print it. That's why I have commented it. If you try to print the statement once again, because there are only 3 objects, so you know, the cursor or the control will flow out once you have reached to the end of the objects, that is, you know, third object is printed. But if you try to, you know, access more, use next method more times, then it is going to raise stop iteration exception. So it's better just to have a check whether you know, the more objects are left or not. So here in this case, if you try to access the fourth object, then it will throw us an error. Else, if you don't want to, you know, if you want to escape the manual checking, then you can just work with try catch exception handling statements also. So what we do is we now try to run this code and see what output do we get. So here I run the code by clicking on the run method, and here goes the output. So you can see it is printing all the 3 string statements. This is string 1, this is string 2, and this is string 3. Next time I had commented the next print statement, the last fourth print statement. That is why you cannot see any error. But if I uncomment it and try to implement it, it is definitely going to throw an error. I suggest all the users to stop here, pause here for some time, just give a thought to it and try to implement this, try to understand yield more by implementing several codes, try to get a deeper knowledge about yield statements. Now, here on your screens, you can see a demonstration for generator expressions and list comprehension. Let us discuss about these 2 concepts more. So, list comprehension basically tries to figure out, you know, some output from the list without using any function or without using any further code. It's a single line comprehension. That means it's a single line expression only, which is calculating something, some values out of the elements of the list. Like you have a list here with the numbers 1, 2, 3, 4, 5, and you are trying to print list comprehension output. So you have basically created a variable LC1 which demonstrates list comprehension, and within the square brackets, like square brackets is used to produce output for list comprehension as well. So now you are using I I double asterisk I in list one. So what it's going to do, it's basically trying to calculate the power, okay, the 2's power of each and every element present in the list. So whenever you want to, calculate power, or you want to square each and every number of the list, you can do it like that. So double asterisk is going to calculate the power of each and every element raised to 2. Now you are not using any for loop, you are not using any iterator, you're not navigating through each and every element manually, okay, through codes, through either loop or something else. But here you are directly able to go through the list one. Within this expression, you are using for loop for iterating through each and every object of list one. Okay, so you are not using a bigger manual code, rather you are concising or comprehending the complete loop and complete iteration code within a single line, within this square bracket. So this is how you can work for comprehension. But instead, if you would have written a manual code, it would have been a bigger for loop, then you had some print statements, some calculations. But you can escape all of them without any difficulty. You don't need to define a function or call it or do something else. Rather, you can just put a square brackets, comprehend the entire code, just write down what expression you want to calculate, like you want to calculate the square for each and every number, in which, in what, in the list. So you can use the smaller for loop for I in list one, which will definitely iterate through each and every element of list one and calculate the square of each of them. So you can just print this list comprehension. In the same way, we can work with generator function. The only difference is like the square brackets as we use here for list comprehension are replaced by parentheses in generator expression. It's exactly same because it is also going to work on the same thing. It is going to calculate the square of each and every element in the list, but through generator expression. So you are using GE1 as the generator expression, and within the parentheses, you are putting I raised to the power 2 for I in list 1. So again, it is going to iterate through each and every value in the list and going to calculate the square of that value. So you can just print GE1 to find out the generator expression. Now, one thing more, just try to understand this particular thing. There's a lot of difference between comprehension and generator expression. When you are working on list comprehension and trying to print it, it is definitely going to print the output in the form of list. But when you try to print this GE1, it will not print the entire expression, because this is expression. This is some object. This is not the values. Okay, you cannot access direct values with the help of the name GE1. Rather, this is going to print the memory location of that expression and not the values in that expression. So as I told you, if you want to work on generator functions and generator expressions, you have to use the next method to iterate through each and every value. So what you are going to do, you have to work with the next method again and again till you have any elements in that generator expression. So you're going to work with next G1 4 times in order to get 4 values out of that generator expression. The only disadvantage of using generator expression is that you need to specify manually what is the end limit of that expression, because if you do not specify and if n number of times your expression is going to list out values, then it may give rise to, state error. It may give rise to expression errors. Like stop iteration exception may be raised up, okay, in case all the values have been finished. So just to prevent that, you need to do exception handling yourself. Fine. So let's see and try to find out what output do we get after we try to print list comprehension and generator expressions. So we run this. Fine. Just see here. The list comprehension output, we can see it is printing the entire list, calculating the square of, all the values till 1, 2, 3, 4, 5. So it is going to print the values for LC1 if we are trying to print. But if you are trying to print GE1, that is generator expression object, then it is going to, print the memory location. So you can see a hexadecimal memory location for that generator object. Now, when you are using the next method to get the values, then you are actually able to get the values, say 1, 4, 9, and 16. So you can use a for loop and you can do try catch handling, exception handling yourself, where you can check for that exception. And if that exception occurs, then you can definitely break out of the loop. So this way you can work with it. So let's see how we can work with the loop and exception handle itself. So I put the code print exception demo with generator expression. Okay, so this is the message that you are going to see. So what I do is I take a while loop, which is going to work infinitely through the to statement. And now here in the to statement, I can do one thing. I can just take print next GE1. So it will print next GE1 every time it is going to get a value. Now, how to break out of it? For that purpose, you need to go for try-catch exception handling. So what I do, I put these statements in try-catch. So we can put try here, and we can have a print statement within this try block. Now, after this, one thing importantly to understand is every try should be accompanied with some except statements. So there must be some except statements we need to put. So let us put an except block here. So I press enter and move to again. Now except block. Now, which type of exception? It has to be stop iteration exception, which will raise when no more values are left for iteration. So once you get to stop iteration exception, what must be done? It must be followed by a break statement. So whenever you are reaching to a point where no more values are left and this exception stop iteration is being raised up, you need to break out of them. So this is how you can work with it. So what I do before actually implementing this loop, let me just comment the above statements, because if they will be executed, then automatically we will be out of the iteration, and it will always raise this error first of all. So we need to just comment these lines, and now we can work through the while loop. So let me run the code and see the output for you. Okay, now just see here. We are getting this message exception demo with generator exception, and this loop is going to work with each and every iteration, with each and every value present in the list, and it is printing the square of each and every value 1, 4, 9, 16, 25, and after which, the last value is over, it will not move to the next value, rather it will just break out of the loop. So this is how you can work with list comprehensions also and generator expressions also. Let's see what we have in store in the next topic. Let's see some of the applications where you can use generator functions. Okay, so suppose we need to create a stream of Fibonacci numbers. Adopting the generator approach makes it trivial. We have to call the next method only to get the next Fibonacci number without bothering about where and when the stream of the number ends. So it is very easy to go for n length of Fibonacci numbers. A more practical type of stream processing is handling large data files such as log files. So generators provide a space-sufficient method for such data processing, as only parts of the file are handled at a given point of time. So we can also use iterators for these purposes, but generators do provide a quick way, because every time we don't need to write the next and item methods here. We can just use the next method as I showed you in the loop. You can work with it. You can call it once again. And in the try catch block, you can just put the ending condition through except block and handle for stop iteration and break out of the loop. So in this way, it's easy and code efficient, time efficient and code efficient when you use generator function instead of iterators. Let's now talk about what are decorators in Python. Let us now discuss what are decorators in Python. So decorators are special tools of Python. They enable to modify the defined function behavior. They provide the flexibility to wrap a function inside another function without even modifying it. In decorators, functions are passed as an argument into another function and then called inside the wrapper function. It is known as metaprogramming because a part of the code attempts to change another part of the code while interpreting it. So in Python, we can define a nested function, that is a function inside another function also. So a function can also be passed as a parameter to another function. So this is also the essence of decorators, wherein you can use decorator functions and create them with the help of nested functions. So function can also return another function in Python through the help of decorators. Let's practically see how we can work with decorators in Python. Now, on your screens in PyCharm ID, you can see here we are trying to implement decorators using nested functions. Okay, so what we're trying to do here, we have defined a main function inside which we are defining two more functions and calling them. So this is how you can work with nested functions, wherein one function is being defined into another function and is also being called up there. Let us see further. We have a main function definition inside which we have a print statement. Say we are in main function. Then we have a function one also defined. This is the first nested function. In this, we are writing the print statement. This is first inner function. Now we also have another function, say function two, which is defined again in main function. So this is also having a print statement. This is second inner function. Now inside this main function only, we are trying to call func1 and func2. And furthermore, from the outside, we are trying to call the main function. So the actual execution begins here when we are calling the main function. So the actual execution begins and it is going to print the statement. Then these two functions, func1 and func2, are called, which are also executed. So you can say indirectly we are executing func1 and func2 by calling them from inside the main function. This is not a direct call, rather this is total indirect call from one function to another function. Okay, so this is, why it is decorator, because you are trying to decorate your code by manipulating the callings, the function callings, and arranging the functions in a way that they look, fancy. They look, something very typical. Although they are not doing much typical work, but, they look fancy. They look decorated. So that's why they are known as decorators. So let's run the code and see the output, what we get here. Okay, so now you can see here, first of all, it is calling the main func1 is calling, the main function is being called and it is printing. We are in the main function. Then furthermore, it is defining the func1 and func2 and these two functions are also being called. So it is printing, this is inner function and this is second inner function. So you have not made any direct call to func1 and func2, although, but they are being called up indirectly through the main function and they are being completely executed. Now here again on your screens, you are seeing another decorator function where we are using function as a parameter. So it's also a fancy function which is using, actually passing another function as a parameter. It's not calling it directly, but it is passing that function and indirectly through arguments, you are making a function call. Let's see how. So we have a function definition for add func, and wherein you are passing two parameters, num1 and num2, and you are returning the sum of both the arguments num1 plus num2. Similarly, you have another function, say subfunc, and again you are passing two parameters and you are returning the difference between the two arguments num1 and num2. Furthermore, this is the main function, the demo function, which is having, if you see, the func1 as the function argument. So this is the function argument that you are passing along with two number parameters. So what it's doing, it's actually using another variable, say temp, and making a call to this func1 by passing the two arguments num1 and num2 to that function. And furthermore, it is returning temp. So you can see here, this demo function is taking func1 as the parameter and indirectly calling it through the parameters and finally returning the result in the form of temp. Now, at the time of function call, like when I'm calling demo, because I will be using this demo directly while using add func and subfunc indirectly. So I'm calling the demo function and I'm passing add func as the first parameter. That is in function one, the parameter that is being taken up is add function. Then the two parameters are 50, 50 for num1 and num2. And in the second print statement, again, we are calling the demo function with the function name as subfunc and we are passing two parameters 50 and 20. So you can see, well, first time add func will be called and it is going to take up these two numbers 50 and 50 and return the sum of both of them. Similarly, when subfunc will be taken, it is going to return the difference between the two numbers 50 and 20. So indirectly, you are passing functions as parameters and you are returning the values and getting the results. So this is also a fancy decorator function because you have tried to, decorate the code, although it's not doing a much hype work, but it's, decorated or complicated code that you are showing it to be very fancy. Fine. So let's run the code and see what output do we get here. So we run the code and what we get is, okay. So you can see first time it is running add func and passing two numbers. So it is 50 plus 50, output is 100. Second time sub func is being called and output is 50 minus 20, that is 30. So this is how you can work with decorators, either by passing functions as parameters or through indirectly calling functions from another function. That is one function being called from another function. So these are the two ways where you can use decorators concept. So decorators is a concept, it's a logic, it's an implementation style of working in Python. Now guys, it's exercise time for action. So you are given three numbers, say A equals to 2, B equals to 5, and C equals to 100. Also given a list of some numbers. So you need to write a code snippet to check which of these is a prime number in the list using iterators. Nextly, you need to write a code snippet to get the factorial of a number in variable B using generators concept. Thirdly, you need to write a code snippet to print Fibonacci series starting from a number in variable A and ending at the number in variable C. That is, you need to create Fibonacci series from 2 to 100 numbers using generators concept. Finally, you need to write a code snippet to reverse a number, say 565, and check if it's equal to its original number using decorators implementation. So I hope it's quite tricky, but you can easily go through these assignments and work on each of them. It will help you to upgrade your skills in these advanced concepts of Python's, namely iterator, decorator, and generator. So let's catch up in the next lecture. Till then, practice well and happy learning.